Hi guys, we're going to be learning about compound interest today. So we are going to be looking at an example real fast. So Yadira deposits at $1,000 in a savings account that pays 6% interest. This is going to be compounded semi-annually. So we want to know what is her balance after 1 year. So we have the principal, which is $1,000. We're going to be identifying our variables first before we plug it into our simple interest formula, which is the I equals PRT. Our interest rate is a 6%. Remember, you have to put that percentage into as a decimal. So we are going to move that percent sign 2 places to the left, making it 0.06. Our T is in time, as in 6 months, or you can do 6 divided by 12, which would be 6 over 12, like we learned before in our last set of notes, or it could be 0.5 as a year as a decimal. This is our formula again. Our interest equals our principal times our rate times our time. And now we're going to go ahead and actually look at the values of our chart here. So if we are going to be talking about compound interest, what compound interest is actually going to be, we're going to be discussing how we go about doing the, how many times we actually have to do it. So number of times we're going to do our first time here. So when we go to our first time here, we are now going to look at our I equals 1,000 times our 0.06, which is our interest rate, and then the 6 divided by 12 equals 30. So we have now compounded our interest one time. We've calculated interest one time so far. So we're going to add that $30 to our original principal of $1,000. That gets our new principal of $1,030. Our second time we're going to do this because we're doing semi-annually. So we want to make sure that our semi-annual right here, we are actually going twice. So now we are going to take our new principal, add it to that 1,030, and we're going to still use all of our same interest rates and our time, so 6 over 12, and we're going to multiply that divided by 12, and that equals $30.90. So we gain another 90 cents of interest, making our new principal, adding it to that $1,030. So 1,030 plus the 30.90, we get the $1,060.90. I want you guys to try and go ahead and do this on your guided notes. So Miguel deposits $4,000 in a savings account that pays $5,000 interest. This is going to be compounded semi-annually, so we're still doing it 2 times. You'll be doing the simple interest formula twice. And what is his balance after 1 year? I will be checking this for you guys when I check your notes. So go ahead and pause the video, try it, use the formula, rewind the video to the previous example to help you out. For our next example, how much interest does $1,000 earn in 3 months at an interest rate of 6%, compounded quarterly? So what is the balance after 3 months? So we need to go ahead and identify our variables. So our principal is $1,000. That was our $1,000 that we have in the account already. Our interest rate of 6%, I need to move that percent sign 2 places to the left, making it 0.06. Our T for our time is compounded quarterly, so that means it's going to be doing it that's going to do it 4 times a year. And then our interest rate is what is the balance after those 3 months. So we're going to be looking for our interest rate. The interest rate is the question mark. So how many times are we actually going to have to calculate the interest? It's going to have to be 4 times. So we're going to use that simple interest and we're going to go 1, 2, 3, 4 based off of that new principal. So let's actually go through this. So our first time, we're going to compound it using our simple interest formula. So I equals P was the principal of 1,000. Our interest rate was the 0.06. And then there's every 3 months out of the year, so that we get to do our interest rate 4 times. So 3 out of 12. Again, if you guys are multiplying, you're multiplying your calculator 1,000 times 0.06 times 3. Hit enter, then divide by 12, and that will get you 15. We're going to add that $15 to our original principal of $1,000, making it $1,015. We're now going to use that new principal on our second time around here. You will see that we use all the same interest rate, the time, and now we multiply the 1,015 times 0.06 times 3, hit enter, divide by 12, and we get $15.23. Now we're going to add that $15.23 to our 1,015, getting our new principal of $1,030.23. Again, you're going to take that new principal, bring it down for that third time using the same interest rate and the same amount of time, but this time we get $15.45. We're going to add that $15.45 to the $1,030.23, making our new principal of $1,045.68. Using our new principal for that last time, this last quarterly time, we're going to have that 1,045.68 be multiplied by the 0.06, same interest rate, and the same time, multiplied by 3, hit enter, divide by 12, and you get 15.69. Adding that 15.69 to the 1,045.68, you're going to get the $1,061.37. Okay, so if I went too fast, you guys, please slow down. I walk you through each process. Please rewind, slow down, pause, whatever you guys need to do in order to follow along on how to calculate our compound interest. Now I want you guys to try, so you really will be pausing the video here, trying that example. I will be checking this for you on your notes when I actually see them. So how much does $3,000 earn in 6 months at an interest rate of 4% compounded quarterly? Your compound interest formula now, we are going to be using let's actually go back here. So I want to kind of go over, so go ahead and write down your compound interest formula. So B equals P times 1 plus R divided by N, close your parentheses, to the NT power. So the B stands for your ending balance. The P stands for the principal or the original balance that you had in your account. R stands for your interest rate. Make sure you always have that interest rate expressed as a decimal. It will be always given to you most likely as a percentage. N is going to be the number of times of interest is actually compounded annually. So when we say annually compounded, that's 1 time. If we say quarterly compounded, that's 4 times. So that's we are looking to see how many times it's actually going to be compounded every year. And then T is the number of years. So for example, we have Stephanie depositing $1,650 for 3 years at 3% interest compounded daily. What is her ending balance? So we want to try and figure this out. What would we have to do if we compounded daily? How many times would we actually have to actually calculate with our simple interest formula if we compounded daily? Any guesses? That's right, 365 times. We would have to do that simple interest formula, just like we did with our quarterly right here. We have to do this 365 times. I'm guessing you guys don't want to do that. So that's why we're going to use this formula. It's a lot faster. It helps us out. So we're going to identify our variables. So our principal is the $1,650. Our interest rate is the 3%. Again, it was given to you as a percentage. And now it's going to be 0.03 as a decimal. N is the 365 times it's going to be charging you interest. Compounded daily, in that 1 year, it's going to charge you 365 times that 1 year. And then T, our time, it's going to be for 3 years. So we're leaving that money in the account for 3 years. So we're going to go ahead and actually use our compound interest formula because I do not want to calculate that using the simple interest formula 365 times. So once we have identified those variables, we're going to go ahead and substitute them in. So we see that we plug in our principal, 1 plus our interest rate, divided by the number of times it's being compounded that year. And then we're going to bring it up to the exponent of the number of times it was being compounded that year times the number of years, 3. And then when we put that in our calculator, make sure you're using your PEMDAS rules. So when you use the PEMDAS rules, we have our parentheses. So you're going to do whatever's in the parentheses. It's actually division first. So 0.03 divided by the 365. Hit enter. And then you're going to press 1 plus 1. And then once you have that solution, you're then going to do separately 365 times 3, hit enter. Whatever you got for this value right here, inside the parentheses, whatever you got for that is what you're actually going to bring to the little caret on your calculator to whatever power you got when you did 365 times 3. Hit enter. And then your last thing you need to do, don't forget to multiply by that $1,650 or $1,650 for the principal. And then that's going to get your $1,805.38. Okay, so I want you guys to actually try this formula out. I will be checking for this one again. Make sure you're rounding to the nearest cent because we're talking about money. And then I will be checking this for you guys in your notes. Good luck. Hopefully, if you calculated it, I want to make sure you guys are actually getting this. If you're actually plugging it in the calculator right. So your answer you should be getting is $2,743.45. If you did not get this answer, go back, make sure you put that 3.1% as a decimal. You're going to make that decimal 2 spots to the left, so it should be 0.031. Go back, make sure you guys did all your calculations. Slow down, work it through the calculator, and your answer should be $2,743.45. All right, when you guys finish that, your homework is going to be page 148 through 149, and you only have 3 problems, number 3, 8, and 11. All right, you guys, until next time, thanks.